Hey guys, welcome back to Trick Code. Today we're doing another Brainstellar Quant puzzle. This one is called Tigers and the Sheep. Let you guys go over it. So basically, we've been given an island on which there are 100 tigers and one sheep, and all the tigers are intelligent and want to survive, but at the same time, they prefer eating sheep over grass, right? So focus on this line over here first. The tigers don't mind being a sheep, but they have a risk of getting eaten by another tiger. Why is this? Because let's say there's two tigers and one sheep. So the scenario is basically that both the tigers are tempted to eat the sheep, right? So if one tiger goes and eat the sheep, then the sheep disappears. This tiger becomes the new sheep, and the second tiger, the tiger that was left, now might be tempted to eat the sheep over here. So the first tiger has the risk of getting eaten by another tiger once it becomes a sheep. And just to clarify, there can only ever be one sheep, right? Because from this line over here, that if two tigers attack a sheep, only the first tiger to bite converts into a sheep. This basically is trying to illustrate that at any given moment of time, there's going to be one sheep always. It's that one tiger converts to one sheep, and the sheep before that just disappears, or you can say dies. Also, try to focus on this line over here. The tigers can live on grass, but they want to eat sheep, as we just mentioned. If a tiger bites the sheep, then it will become a sheep itself. But this also has to factor in the fact that the tigers don't mind being a sheep, but they have a risk of getting eaten by another tiger. So basically, how a tiger would approach this is that if it feels like by eating the sheep, he or she himself will survive, then it will eat the sheep. But if the tiger feels like it will not survive post eating the sheep, it simply will just not eat by the sheep. So just to write these 2 points down, a tiger will bite the sheep if and only if he thinks it'll survive, and the tiger won't bite the sheep if it basically does not feel like it'll survive, right? So having these basic points noted down, we can now come to the solution. Oh, and by the way, if a tiger does not bite the sheep, then it will basically just survive on grass forever, right? They all of the tigers don't have a necessity to bite the sheep, but they will if they think they can survive. Otherwise, they'll just survive on grass. So just to reiterate some of the few important points. So if a T bites the S, that particular T becomes the new S and the old S dies. And this way the number of S is always, or the number of sheep are always equal to one and one only. And the actual problem, the main question we've been asked is, will the initial S, when the case is that there's 100 tigers and one sheep, will this particular sheep survive or not? That's the problem that we have to answer. So just to give you guys a hint before we come to the real solution, whenever we've been given like huge numbers like 100 or 1000, or for that matter even 10, and we can't really wrap our heads around the situation in those cases, it's always a good bet to try to think of a much simpler dumbed down case. For example, here, so since we've got 100 tigers and one sheep, how about we think about the case where there's just two tigers and one sheep, or three tigers and one sheep, and maybe we can find a pattern, right? Four tigers, five tigers, and so on, and we can extrapolate those results to this case. So this is the approach we're going to use for our answer. And so let's start with the case of two tigers and one sheep. So actually, guys, I just figured out that there's an even simpler case, right? There's just one tiger and one sheep. We can't have zero tigers and one sheep, and we come to that just a second. But there's always going to be one sheep, like we established that at the beginning of the video. So this is a basically base case. So when there's one tiger and one sheep left on the island, what happens is the tiger will just eat the sheep because why not? There's no risk of being eaten once it becomes the sheep because there's no many tigers left. So this basically boils down to the case of two tigers and one sheep because the last tiger will definitely eat the sheep. So using this case, now if we were to think about the case where there's two tigers and one sheep, now imagine this. So we've got one sheep, we've got two tigers over here. Now, both of these tigers know that if it so happens that we reach this case where there's only one tiger and one sheep left, then that the remaining tiger gets to bite the sheep without any consequences. So each of these tigers would wait for the other tiger to eat the sheep because if if as a tiger you're the one who bites the sheep first, then you're just going to be get bitten by the second tiger because you've become the sheep for the first case. So in in the case where there's one tiger and one sheep, the sheep isn't safe. Now when we've got a case of two tigers and one sheep, none of those tigers want to become the sheep of this case, right? None of these tigers want to become the sheep in this case because the sheep over here doesn't survive. So what is going to happen is both of these tigers are not gonna bite the sheep at all. They're both gonna end up not doing anything because they know that they eventually won't survive. Now, using this case for the next case, which would be three tigers and one sheep, since there's three tigers now, and there's one sheep, each tiger knows that if it so comes to the case that there's now just two tigers and one sheep, then the sheep will survive in that case, right? As we just talked about over here, that in this case, the sheep survives because none of the tigers would want to become a sheep for this case. So they basically leave the sheep alone in this case. So now, no, now since each of these tigers know that whichever tiger gets to bite the sheep first becomes the sheep of the second case, and he and will survive, right? So in this case, where there's three tigers and one sheep, knowing that uh first tiger who gets to bite the sheep basically becomes the sheep for the second case, knowing that information, the sheep of this case won't survive because the tigers are going to try to race to bite the sheep first because they know that that tiger who gets to bite the sheep will eventually be able to survive. So in this case, basically what the conclusion is that when there's three tigers and one sheep, the sheep of this case does not survive. For two tigers and one sheep, the sheep does survive. And for one tiger and one sheep, the sheep does not survive. So now extrapolating this to four tigers and one sheep, it's using the same logic. The four tigers over here know that if tiger bites, if any one of the tigers bites the sheep, then it becomes this case, and in this case, the sheep does not survive. So none of these tigers. So none of these tigers would want to bite the sheep. So in this case, basically what happens when there's four tigers and one sheep is that this sheep does survive. And this now starts to become a pattern. So for five tigers, the sheep does not survive, and for six tigers, the sheep does survive, and it just keeps on going. So as you can see, for when there's an even number of tigers, the sheep does survive, and when there's an odd number of tigers, the sheep does not survive. So for the case where there's 100 tigers and one sheep, which is basically this case, the sheep will survive. And I've also provided the summary evolution over here. If you guys want to pause and go over it, basically a summary of whatever I just explained right now. Thank you.